In this video, we are going to be looking at IV curves. So, what is an IV curve? Sounds fancy. Let's break it down. I stands for current and V, and those are going to provide some axes of a graph. So you have an empty graph that looks like this. I is along my y-axis and V is along my x-axis. And curve refers to the line that you get on the graph, which is sometimes the curve and sometimes is not. Brilliant. And the point is, different components produce different IV curves. You need to know how you can take a particular component and find the IV curve. So you're going to want to set up a circuit like this. You've got your ammeter in series and you've got your voltmeter in parallel across the component that you're interested in. So in this circuit, I am interested in finding the IV curve of my resistor. Your variable resistor is there so that you can change the resistance of your circuit. If you change the resistance of your circuit, then you will change the voltage that is over your resistor and the current that is through your circuit. That will allow you to take multiple readings of voltage and current. You're going to do that and you're going to put them in a table that would look something like this. You can plot your IV curve. And for a resistor, you would end up with a curve that looks like this. Right, so more of a line. But we don't just want to do this for resistors, do we not? No, we want to do it for bulbs and diodes too. But the good news is you just do the same thing, but you swap your resistor in your circuit for a bulb or for a diode. We're going to imagine that you've done all three and you are going to end up with some beautiful graphs that look like this. Let's check out the resistor one first. This graph is directly proportional. By that I mean it is a straight line and it goes through the origin. Now, the resistance of my resistor equal to 1 divided by the gradient. What that tells me is the larger the gradient, the smaller the resistance. Remember, gradient is all about steepness of your line. So the steeper the line, the larger the gradient, the smaller the resistance. Take a look at this graph here. Which resistor has the largest resistance? Well, resistance is 1 over gradient, and the blue line is the shallower line with the smaller gradient, so that one has the larger resistance. Okay, now let's look at our IV curve for our bulb. Wow, this one at least actually lives up to the name curve, and it sort of loosely takes an S shape. Let's zoom into this quadrant here. Can we see as the current increases, the gradient or steepness of my curve gets smaller and smaller and smaller? That means that my resistance must be getting larger and larger at higher currents. At higher currents, the temperature of your bulb increases, and so the resistance of your bulb increases. For more information on that, check out this video on current and heating. Now you can use this graph and you can find the resistance of the bulb at any point. Just need to find the current and voltage at that point. So here my current is 3 amps and my voltage is 15 volts. To find the resistance, I use my equation V equals I times R. And so resistance is voltage over current, which is 15 divided by 3, 5 ohms. Okay, and last but not least, let us look at our graph for the diode. You can see a very flat line here up to a certain voltage. If it's really flat, then my gradient is 0, and that is telling me my resistance is extremely high. Once my graph hits that threshold voltage, gradient gets a lot steeper very quickly. A large gradient, a small resistance. This graph takes this shape because my current, when it flows through a diode, can only flow in one direction. That's why there are no values for current in this part of the graph here. Okay, hope you found that helpful. Please make sure you download the notes and click on the next video to see LDRs and thermistors.